So I've been playing D&D for a couple years now, and one of the things that I've wanted to do more of is physical terrain. But it just takes so much time to build, to paint everything that I haven't really done as much as I want to. Usually I just end up using digital maps, which look great. I use animated maps on a TV and they look fantastic. But there is a whole other dimension, literally, to the game when you have physical terrain. Recently, I did this witch's hut for a session and I used it in conjunction with my digital animated map and it worked out great. Having physical terrain gives your players something tangible, something that they can really visualize strategy with. It gives them more options and it's a lot more immersive. Now lately I have been printing and painting more scatter terrain. Things like these ruins or these rock formations. Things like this to have on hand are great to just add them to your map or throw them on the table and give your players something a little bit more to interact with. Now you might say that 3D printing things like this is cheating. And it kind of is, but it's so simple and the results are great. I would like to make some more physical stuff from scratch, but again, that takes a lot of time and I'm more worried about planning a session than I am spending several days building physical terrain from scratch. So along with wanting to do more physical terrain, on top of that, I've also really wanted to incorporate some actual lighting effects into the terrain. Things like torches or a fire pit or a brazier, things like that, illuminated elements that really make the terrain come to life. So when you add an electronic element like that to your terrain, of course you've got to power it. And the question is, how do you power it? Well, the simplest way is with just a simple DC adapter like this, and then you use some standard barrel connectors, add this to your wiring, and you have all the power that you need. The only downside is you have a cord that you have to run to your map somewhere. Maybe you have a setup where you can hide the cable, but more than likely you're going to have a wire running into your board or your map somewhere to power all of your electronic elements. The other option is a USB power bank, something like this. These things are great because it gives you the voltage that you need for most scenarios. There are some limitations, but another one of those limitations is the fact that this is only going to have so much charge to it. Eventually it's going to die. It may last you a whole session, it may not. Second, you have to find some place to put this. Maybe you have somewhere in your terrain you can tuck it away and you won't know that it's there. And there are smaller ones than this that are maybe easier to tuck away, but then those are obviously not going to last as long. So you've got those two options, both with their limitations and both with their benefits. But what if there was another way? Imagine you're getting ready to start your session. The players are all sitting at the table and you walk in carrying this really cool map that you built. You set it down on the table and as soon as you put it down, it comes to life. Torches light up, braziers light up, you've got fire effects, maybe you've got some other elements, all comes on as soon as you place it on the table. No cords, no battery banks, just wirelessly powered. That is exactly what we're going to do in this video. So stick around to the end to see how we do it, and along the way I'm going to show you how I'm going to build these individual elements. I'll try to keep it concise so this isn't too long, but I do hope you watch so that maybe you'll take away some cool new ideas on how to build your own lighting effects into your terrain. So for the actual fire elements themselves, I'm going to use this 3D printed brazier model here. We'll have to modify it. We're going to drill a hole all the way through it to run the wiring and carve out part of the top to fit our LED. And then for the torch, we're going to use this model here. And first we'll have to cut off the fire portion of the model, carve out part of the top to fit the LED, and then drill a hole to run our wires. So let's get started on modifying these. All right, so my parts are ready to go. I've drilled a hole all the way through the brazers from one end to the other to run the wire. I've also bored out a bit at the top to fit the LED filament. The wall sconces, I've scooped out a bit of the top there and drilled a hole all the way through it for the wiring. So the parts are ready to go. Now I can move on to building the rest of it. Okay, let's wire up some LEDs. These are the LEDs that we're using. Let's wire one up and I'll show you what it does. I'm going to put a little bit of flux on here so that I get better solder flow. All right, let me solder my leads on here. And with that one wired up, we're going to test it with our button cell, and it is working. And again, polarity matters with these things. So now I'm going to actually twist the wires together. This is why I'm using the enamel coated wire rather than a standard wire that has a regular rubber or silicone insulator. This allows me to fit it in through smaller holes, or just makes it a little bit more discreet. Plus this enamel magnet wire is also pretty rigid. So it makes feeding it through a little bit easier. So that's one done, and several more to go. I want to cover the circuit board a little bit. One, to protect it, and two, the shrink tube will actually give me a little bit of grip, because these are just going to be friction fit into the braziers. So that'll kind of help hold them in there, but I just like having a little bit of insulation and protection around the circuitry of the LED. And I just need to make up several more of these and we'll be good to go. Alright, so now if I take one of my finished LEDs and I run it through the brazier, comes out the bottom. What we end up with is the wire showing down through the bottom, which isn't terrible, but we can do better. So you see how it's running through down the middle. So to clean that up, we're gonna take this back out, and we're gonna take some of this plastic tubing, slip it up in here, and we're gonna use that to give it basically a channel for that wire to run through so that you can't see it, and then once it's painted, it'll just look like it's part of the model. So we're going to secure this not with super glue, but we're just going to secure it with resin. I'm going to flare the end of it a little bit so that when I run the wire through, it won't get hung up. So just a little bit here, not enough to crack it. So I'm going to put this in through the bottom, just a little bit into the interior of the brazier. It doesn't need to go in very far. And then I'm just going to use some resin from my resin printer, and I'm going to just dab that on there, let that flow into there, and then I'm going to cure it on this UV light here. Super glue would work, but I don't want to take the chance of the super glue running everywhere and kind of making a mess, or eating away the paint job, or eating away the plastic tubing. So a little bit of resin. All right, see, now that's not going in. I'm going to do the same thing on the other end. Doing this before I snap it off. So I'm just going to put a drop on there, let it flow around it, let it get down in there just a little bit, and then cure it. Okay. So again, that's really in there. This won't take any type of stress, so it doesn't need to be super strong. So then I'll clip that off flush. And I'm going to flare the bottom out just a little bit from the way it was crushed by the clippers. And now if I take my LED again. I'm going to make sure the ends are fairly close together so that it doesn't get hung up. Feed that down through the middle. Yeah, piece of cake. The little bit of heat shrink gives me a good friction fit. So now it comes through the bottom, but you can't see the wire. And then once I paint that tube black, you won't even know what's going on. It'll look like it's just part of it. Slide right here. Yep, there we go. So that'll hide the tube there. And we've got our lead wire, and yeah, that's it. Now I just need to do that a few more times. All right, the brazers are all primed, ready to go. Next thing I'm going to do is make some fire element for it, and for that we're going to use the old polyfill method. I'm going to go through the airbrushing of this fairly quickly. There's plenty of videos out there that can show you how to do this better than I did. Basically using 3 or 4 colors here, starting with a yellow, adding some orange, and then to a red, just to have kind of a gradient effect with a little bit of black on the ends to kind of sell that fire effect. And it works out pretty well. I could probably spend a little bit more time on it, but this is good enough for now. All right, so I've got all of my wall sconces painted. Here's what they look like here. Here's what it looks like. Next step is to add the LED to it. These are the LEDs that I'm going to be using here. These are a red 3-volt micro LED. And when they say micro, it is micro. With our painted wall sconce, we're going to take our LED, feed it through the hole. I'm going to leave it sticking up just a bit. With our LED secure, let's add our polyfill flame element. Grab this, and I'm just going to shove it over top of it. And then just use something. I'm gonna shove it down in there. I might hot glue it later, but for now I'm just gonna stuff it in there. All right, so that is our fire element wall sconce as it is. We've got a red micro LED in there, and it looks pretty good. All right, so I've got all my wall sconces made up. Got the wiring, got my flame element, they're painted. Now I want to install them into some terrain to complete the effect. So for demonstration purposes, I'm going to be installing it into this 3D printed terrain from Loot Studios. This is kind of a modular dungeon cave set. They're printed hollow, so easy enough to run the wiring through it and out the bottom. Got a couple different components of this terrain that I'm going to mount these brazers to, and we'll see what it looks like when we're all done creating kind of a demo scenario for all of these flame effects. Alright, I'm just going to install the wall sconces on each of my wall pieces. Drilled a hole just big enough for the wire to fit through, and I'll run it out the bottom. And then rather than super glue it, I'm just going to secure it to the wall pieces with a bit of resin, and then cure it with UV. Okay, this is going to be my map. This is a piece of XPS foam. Flip it over here. See the back of it there. Standard piece of XPS foam, gridded out and painted. It's got some other little details in it that I've made. So this will be my foundation for this particular map. So to be able to connect and disconnect my lights, I'm going to use these connectors here. They're really small, easy to tuck away. And they'll be perfect for making this modular, so that I can unplug them, reconfigure it, plug it all back in without having to take anything apart. So here's what this will look like when they are all done with the connector installed, and then I'll do the same thing with all the brazers, add a connector there so that they can easily be disconnected. Alright, now all of my fire elements have their connectors on the bottom of them. All of the brazers have been bored out in the bottom so that the connector and the wire has a place to go when it's sitting flat on the table. The brains of this build are going to be two microcontrollers. One is a Wemos D1 Mini. It's an ESP32 microcontroller. You can buy them on Amazon, they're really cheap. Added to that, the Harlech Castle board from Tronics. That's this guy here. If you're not familiar with Tronics, I highly recommend you check out their YouTube channel and check out their Etsy store. But they're great boards for various functions. This one in particular is going to allow me to connect up to 8 different LEDs and give me the option of adjusting brightness, or basically adjusting the program that is going to run by way of these potentiometers that are on the board right here. The Wemos D1 is going to actually have the software installed. It has a micro USB connection in the bottom there. That is where you plug it into your computer to install the code that is going to run the commands to the Tronics board. These basically go on top of each other, something like this. So you basically have a microcontroller sandwich here. The Wemos D1 Mini with the Harlech Castle board on top. Here's the final assembly of the Wemos D1 married to the Tronics Harlech Castle board. I've soldered these pins onto it, but I also did it in a way where they will come apart. That way, if I want to reuse one for something else, or if one of them burns out, I can replace it without having to desolder everything. Also added a buck converter to reduce the 24 volt power supply down to 5 volts. I've also made this ribbon wire to connect to all of my wall torches. Doing it this way makes it really easy to attach each wire and detach it. This is the little Frankenstein connector that I made that all of the pins for my individual wall torches will plug into. This also has a buck converter on it, which will reduce the 5 volts down to 3. Time to connect everything up. I'm going to start with all the torches and plug all of those into the ribbon wire that runs to the Wemos and the Harlech Castle board, and then I will connect all of the brazers into their own separate hub, and then we can see if this thing works. Alright, let's connect the 5 volt power supply and see what happens. It all stinking works. I am honestly surprised this worked the first shot. I would have swore that I would have wired something backwards. A single connection in the wrong polarity would have done it, or any number of things that I would have forgotten. It works. The brazers have their own built-in. The LEDs have their own built-in effects. And then the wall sconces have their own subtle flicker effect, thanks to the Tronics Harlech Castle board. Okay, that's a good start. All right, here's where it gets cool. Everything works as intended. We have our power input here, standard barrel connector connected to a standard power supply. And then our different connections to our two different systems, the sconces and the brazers. So we're going to do this wirelessly. I'm going to be using the Etherdyne wireless power kit. Now this is an evaluation kit, not commercially available, but I was lucky enough to have been given the opportunity to purchase this kit, which is not cheap. So I wanted to play with it in a TTRPG scenario, like That's the whole purpose of this video, is to see what this system could do with a tabletop system. The kit comes with several receivers ranging in voltage from 5 volts up to 24 volts with varying wattage outputs per receiver. For the brazers, those LEDs only require 3 volts, but we're pushing 4 of them. So we're going to be using this receiver here. This particular receiver is a 12 volt receiver, which is more voltage than we need, but we have a buck converter attached to our circuit, which is going to take that 12 volts down to 3 volts, but give us the wattage that we need to actually power the lights. This bigger one, this is a 24 volt receiver, which is obviously way more than we need for the wall sconces, but we also have to power the Wemos D1 Mini microcontroller. That requires 5 volts. So again, a buck converter is in line of our circuit to bring that 24 down to 5, but give us the wattage that we need to power everything. I am an amateur at best. I have no idea what I'm doing. I know just enough to be dangerous, except that this is 12 volts, so it's not really dangerous. So I am not an expert. Consult your local electrical engineer for proper direction or explanation. So this is not a how-to, or maybe it is, I don't know. Do what you will. How the rest of this system works is there is a loop installed underneath my table. It is there's a control box that is the power supply and the transmitter, and there is a loop that runs in kind of a rectangular shape under my table, and that generates the electromagnetic field. The electromagnetic field excites the coils in these receivers. Through fairy dust and magic, you get electricity. So that's the broad version of how this system works. So I'm going to mount these receivers a little bit more neatly underneath our board and tidy up some of this wiring, and we can wrap this up. So that's it for this build. I hope you took something away from this. This doesn't have to be a wirelessly powered setup. That's just a cool party trick. I know not everybody's going to have access to that wireless power kit. But if you are interested in it, I'll put a link below. You can find out more. They didn't sponsor this. But if you're curious about it, you can check it out. All of this can be done powered. You can easily just plug in a simple barrel connector to do all this. So hopefully you learned something on how to power or illuminate these various torches and brazers. The torches or wall sconces were all driven by the Harlech castle board from Tronics, in combination with a Wemos D1 Mini microcontroller that gave them all the flicker effect. The brazers are all just straight wire. The flicker effect that they have, which is basically an animation in the LEDs, are all self-contained. You just give them 3 volts of power and they do their thing. So maybe you learned something on how to make these illuminated elements. I'll put links down below to the components that I used if you're interested in kind of picking those up yourself. This might have been easier to integrate these elements into a more permanent diorama or a more permanent structure, maybe a tavern or a cathedral, where these elements are all just built into it. In this scenario, this is what I had readily available, and I wanted to do it with this modular terrain to where I can change the layout of my dungeon. I can make it bigger. I can reverse all of this and reuse it in a different scenario. So that was the goal with this one, and it kind of added maybe another element of difficulty, making it reversible, making it modular. Probably over-engineered some of it, but it was fun nonetheless. So if you were building something more permanent, like a tavern, and you had a fireplace, or you had torches on the wall, you can see how easily this could be done with wired power or wireless power. Anyway, thanks for watching. I hope you got something cool out of this now. What are some other ideas? What are some other cool elements that I could integrate wirelessly? I considered kind of an illuminated portal of some sort, or maybe some sort of movement. I don't know what that might be. Adding a motor to something and giving it some movement. If you have any ideas, drop it down below. Maybe it could build something else. Anyway, thanks for watching.